Welcome to aminacademy.com. In IB Diploma Mathematics regarding matrix algebra, let us do some solving problems. Look at this example. Let matrix A is 2101. Matrix B equal 1 2 minus 1 0. And matrix C equal 0 3 1 2. 1 2. If A x B equal C, find x. Here, the multiplication of matrix A, x and B equal to C given. Find x. Look at here. First, the relation A, x, B equal to C. Then, xb equal A inverse C. Then, x equal A inverse C inverse B. That is, B go that side as B inverse. Now, we have to substitute the values of A inverse, B inverse in this. Here, first given A, the matrix A is given 2 1 0 1. Determinant A equal 2 into 1 2 minus 0, that is 2. Therefore, A inverse 1 by determinant 1 by 2. Interchange the prime diagonal, that is 1 and 2. Change the second diagonal, the sign. This is A inverse. Like that, we need B inverse. Is 1 by determinant of B. Here B is 1 by determinant is 1 into 0 0 and minus 2 plus 2, that is 1 by 2. Then change the sign of, interchange the prime diagonal 0 1 1 and change the sign of the diagonal, second diagonal, minus 2 1 minus 2 1. Then we have to substitute the relation x equal A inverse C into B inverse. We'll substitute the values, that is x equal A inverse equals half 1 minus 1 0 2. 1 minus 1 0 2. And C equal C is 0 3 1 2. 0 3 1 2. And B inverse is half 0 minus 2 1 1. Now that constant multiplication, half and half take out as 1 by 4. Now we have to multiply these two things first. 1 into 0 0 minus 1. Then 1 into 3 is 3, minus 1 into 2 is minus 2. That is 1 into 3 is 3 and 1 into 3 is 3, then minus 2. That is 1. 3 minus 2 is 1. Then 0 into 0 0, 2 into 1 is 2. Then 0 into 3 is 0, 2 into 2 is 4. then this 0, 2, then multiply with another one, 0, minus 2, 1 and 1 equal 1 by 4. Here minus 1 into 0 is 0, 1 into 1 is 1, 0 plus 1 is 1. Minus 1 into minus 2 is 2, 1 plus 1 is, that is 1, 2 plus 1 is 3. Then 2 into 0 is 0, 4 into 1 is 4. Then minus 4 plus 4, 0. Equal, multiply 1 by 4 throughout, that is 1 by 4, 3 over 4, 4 over 4 is 1, and 1 into 4, 0. So we got this result, that is 1 by 4, 3 by 4, 1 and 0. Next question. Yeah, A and B is given. Suppose A is 1 and 1, 2 minus 1. B is given as 0, 3, 0, 1, 2 minus 3. Here, two matrices are given in that. Find in the simplest form A inverse. Then simplify. Simplify AB into B inverse A inverse. Here, this A and B is given. Then we have to simplify this. That means even without using this also we can simplify this. First, listen here by matrix algebra. What we are doing here, look. A into B into B inverse into A inverse. Then A, B into B inverse is I, identity matrix into order. Then A inverse. Then A into I is A inverse, which is equal to I. Then even here this matrix is not necessary. Then even if you use this A inverse, A into A inverse, then multiply both, it will give I. Next is we have to show B inverse minus A inverse, B inverse into A inverse into AB. You have to simplify this. How? First, B inverse. B inverse into A inverse A into B, which is further equal B inverse. A inverse A is I, B. Then, which is further B inverse I into B is B, B inverse B is I. Therefore, we can write the complete result like AB into B inverse A inverse, B inverse A inverse equal B inverse A inverse AB equal I in general. Next, here suppose x, y, z, x, y and z are going to one order matrix. And AB and A comma B are A and B are 2 into 2. A and B are 2 into 2 matrices and invertible. Then if X equal AY and Y equal BZ, find AB, find X in terms of, therefore X in terms of Z. X is AY, which is equal AY is BZ. X equal to ABZ. Then second one, Y is BZ. Y is BZ. Then Z in terms of X. Z in terms of X. Then Z equal B inverse Y, which is equal further Z equal B inverse is and Y is A inverse X. Therefore B inverse and A inverse X. Then next question. Here condition A square equal given as 4A minus I. Find A inverse. Now A square can be written as A into A equal 4A minus I. Then A equal this A inverse, A goes as this side, A inverse 4 A inverse A minus A inverse I, which is equal 4 A inverse A is I minus A inverse. We need A inverse, therefore A inverse equal A minus 4I. Next is find A. Find A equal I minus A square. Then find A plus A square equal to I. Then find A plus A into A equal I. Then multiply throughout by A inverse, that is A inverse phi A plus AA equal A inverse I. Here A inverse A is I, that is phi I. Then A inverse A is IA equal A inverse I. Then phi I plus IA is A equal A inverse I. Phi I plus A inverse I is A inverse. Therefore, therefore A inverse equal phi I plus A. Phi I plus A. Then one more. 2I equal 3A squared minus 4A. Then here 2I, A squared is split as A into A minus 4A. Here multiply throughout A inverse, that is 2 A inverse I, 3 A inverse AA minus 4 A inverse A, which is equal to A inverse I is A inverse. Here A inverse A is I, that is 3IA minus 4 inverse A inverse A is 4I. 2A inverse is 3A minus 4I. Then A inverse equal 3 by 2. A minus 4 by 2 is 2I. So far we discussed about different types of matrix algebra linear form. Ahead on, please subscribe our YouTube channel.